Phosgene, a chemical compound with a dual nature. Phosgene is a substance widely used in the chemical industry for producing various chemical products and compounds. Not long ago, it was actively used in the production of pesticides, plastics, polymers, and even pharmaceuticals. However, this does not prevent it from being a potent chemical warfare agent. A researcher who lived more than half a century ago described the effects of phosgene on humans through the following case. A strong, healthy 19-year-old accidentally wandered into a cloud of phosgene drifting down a river. Noticing the unfamiliar odor, he quickly left the area and reached the shore. Later, the young man consulted a doctor due to a persistent cough. The doctor conducted a thorough examination, but found no symptoms of illness. Following the doctor's advice, the young man went for a walk to alleviate his discomfort. However, within 4 hours, he was rushed to the hospital with severe pulmonary edema. 5 to 6 hours later, he succumbed to the poisoning. This short but tragic story highlights one of phosgene's most insidious properties: its delayed effects on the human body. In the initial hours after exposure, the affected individual may feel fine and not even realize they have been poisoned. If the gas concentration was low, a person might not even notice its characteristic smell, often described as musty hay or, in some sources, rotten apples. By the time symptoms appear, it is often too late for effective medical intervention. The origins and formation of phosgene is an old chemical discovered over 200 years ago. Its name means born of light, likely because it was first synthesized by exposing a mixture of chlorine and carbon dioxide to sunlight. Interestingly, phosgene can sometimes form unintentionally, both in nature and industrial settings. For example, it is frequently generated in the upper layers of the atmosphere when simple chlorinated organic compounds break down under ultraviolet radiation. From there, it has two possible fates. If it enters the troposphere, it can persist for up to 70 days before decomposing upon contact with moisture. Phosgene is highly sensitive to water and breaks down when exposed to it. If it remains in the stratosphere, where conditions are much drier, it can persist for years, decomposing very slowly. Old plastic foams produced in the 1970s, 80s, or even 90s may release trace amounts of phosgene when burned, as it was commonly used in the production of foams, polyurethanes, and polystyrene. Though the amount released is minimal, inhaling the fumes is still not advisable. There is also speculation that phosgene may form as a byproduct of chloroform metabolism, likely through the action of cytochrome P450 enzymes. However, this process remains poorly studied and is primarily based on theoretical models. Toxicity and effects on the human body. The most recognizable trait of phosgene is its odor, often compared to musty hay or, in some reports, rotten apples. The US Army even issued a poster warning: "Beware the smell of musty hay, wear a gas mask." Another dangerous aspect of phosgene is that it dulls the olfactory nerve. After inhaling even a small detectable amount, a person loses the ability to smell it. This means that even if they remain in a highly contaminated area, they might falsely believe they have left the danger zone. Phosgene is 3 times heavier than air, so in case of a leak, it settles along the ground and accumulates in low-lying areas, similar to chlorine gas. Anyone exposed to it is classified as a stretcher patient, meaning they must be transported lying down, regardless of how they feel. Walking out of the contaminated area is strictly prohibited, even if the person appears symptom-free. The primary treatment for phosgene exposure is managing pulmonary edema, as all other symptoms are secondary. The gas reacts with nucleophilic groups in lipids that make up the walls of lung alveoli. This causes the alveoli to fill with blood plasma, severely impairing gas exchange in the lungs. The resulting loss of plasma thickens the blood, increasing strain on the heart while lowering blood pressure. Due to this mechanism, there is no known antidote for Phosgene poisoning. Treatment is purely symptomatic. If medical intervention is not timely or effective, death typically occurs within 2 to 3 days. However, if the patient survives this critical period, they usually recover fully within 2 to 3 weeks. Industrial use and safety measures. Despite its high toxicity, Phosgene is considered one of the least effective and least deadly chemical warfare agents. In summer, it remains dangerous for about 30 minutes before breaking down, while in winter it can persist for up to 3 hours. Long-term contamination is possible only in enclosed spaces or low-lying areas where the gas can stagnate. For instance, in 1928, a leak from military storage facilities in Hamburg released nearly 11 tons of Phosgene, poisoning over 300 people and killing about 10. More recently, in 2016, a Phosgene leak at a BASF plant in South Korea resulted in several fatalities. To ensure worker safety, employees in industries using Phosgene wear special indicator badges, similar to radiation dosimeters, which track cumulative exposure levels. Since Phosgene breaks down upon contact with water, a simple wet gauze mask can provide some level of protection. More effective protection comes from gas masks, as Phosgene does not affect the skin and only enters the body through inhalation. If a leak occurs indoors, spraying ammonia water is an effective neutralization method, as it reacts with Phosgene and renders it harmless. Proper ventilation is also crucial. Why is Phosgene still used today? One of the main reasons Phosgene remains widely used in industry is its extremely low cost. It is cheaper to produce than drinking water. Additionally, in certain chemical processes, Phosgene is nearly irreplaceable. For example, phosgenation is a crucial step in dye production. It is also used in the manufacturing of polycarbonate, a vital thermoplastic. While non-toxic alternatives to Phosgene exist, they are significantly more expensive and thus used far less frequently.